Welcome to this fluid metering video on the best practices for your pump. Today we're going to walk through the basic operating principles of our pumps, along with some of the general best practices to help you achieve consistent and reliable performance. Whether you're new to fluid metering products or looking for a quick refresher, this overview will give you a solid foundation for getting the most out of your pump. Let's talk about the pump orientation, because how the pump is mounted plays a major role in how well it performs. The ideal orientation is vertical, with the pump head positioned below the motor. In this position, air is naturally pushed out of the pump, and gravity helps pull the fluid downward and away from the seals. That downward pull reduces the long-term risk of leakage. If a vertical mount isn't possible, a 90-degree horizontal rotation is also a reliable option. In this setup, the inlet should be at the bottom and the outlet should be at the top. Since air rises, that makes it easier for air bubbles to escape and keeps the pump operating smoothly. A 45-degree rotation with the inlet and outlet aligned horizontally is another acceptable configuration. It offers similar benefits, but it's slightly less effective when it comes to pushing air out of the system. All of these mounting positions are acceptable and will give you strong performance. The one orientation you should avoid is having the pump head facing upward with the motor below it. In that position, air bubbles can become trapped inside the pump, which can affect precision and accuracy. Additionally, gravity will pull the fluid down towards the seals, increasing the risk of a leak over the life of the pump, possibly even allowing fluid to reach the electronics below. Tubing selection should be matched to both dispense volume and application requirements. For dispensing applications below 10 microliters, a small diameter tubing is recommended to maintain fluidic precision and for easier priming. Tubing durometer, its softness or hardness, also influences flow stability. Softer tubing can dampen pulsation, while stiffer tubing may provide better precision and accuracy. Incorrect tubing selection can lead to cavitation, pressure buildup, or pump seizure. When selecting tubing, it is important to consider your application's needs to get the best outcome from your pump. Fittings should be selected according to the system flow rate and tubing interface. There are a wide variety of fittings that can be paired with our pumps. Our two most popular fitting options are quarter 28-inch UNF fittings. These are used for our low-flow applications up to approximately 50 milliliters per minute, and these are compatible with our low-flow pump heads. The next option is our quarter-inch outer diameter fittings. These are recommended for flow rates exceeding 50 milliliters per minute and are generally paired with quarter-inch tubing. Adapters are available to accommodate alternative tubing dimensions or configurations. Knowing your flow requirements is needed to select both the correct pump and fittings. The dispense tip significantly impacts your ability to dose successfully. A conical tip geometry is commonly paired with our pumps, as it reduces pressure drop, improves flow control, and enhances droplet detachment. A general rule when selecting tip sizing is straightforward. Smaller internal diameter tips produce finer droplets and are ideal for low volume dispenses. Large internal diameter tips generate larger droplets and are suitable for higher volume applications. Using hydrophobic materials helps prevent residual droplets from adhering to the tip. Making the right tip selection can have a big impact on precision and accuracy in dosing applications. Let's go over the key operating parameters you can adjust on your fluid metering pump. First is RPM, or rotations per minute. RPM controls your flow rate when metering, or the speed of your dispense when dosing. Each revolution moves a fixed volume of fluid, so changing RPM directly changes your flow rate when operating continuously. Next is acceleration. Acceleration controls how quickly the pump reaches its target speed. A faster acceleration can help shear a droplet off the dispense tip or get the pump up to your desired flow rate faster. The last parameters are run current and hold current. Run current can be increased for higher speeds or thicker fluids to prevent stalling. Hold current helps keep the pump in position when you're working against a higher inlet or outlet pressure. These adjustments let you fine-tune your pump's performance for your specific application. Pump performance can also be influenced by a few system variables. Fluid viscosity is the first one. Thicker fluids require more torque to move, and you may need to increase your run current to keep your pump operating smoothly. Tubing length is another factor. Longer tubing adds resistance, which can affect pressure stability and overall accuracy. Your dispense tip design also matters. Narrow tips can create pressure spikes, while wider tips may reduce your precision. And finally, any system restrictions, such as valves, manifolds, or long tubing runs, can introduce back pressure that impact the pump's performance. Keeping these variables in mind will help you fine-tune your setup and achieve the most consistent results. Next, let's talk about priming. because proper priming is essential for accurate and consistent pump performance. Priming removes air from the pump head and the fluidic lines. Even a small amount of microbubbles can have an effect on precision and accuracy, especially in microdosing applications. Each fluid metering pump may require a slightly different priming approach depending on the model and the overall system setup. So instead of relying on one universal procedure, it's important to focus on the end goal, a clean, air-free fluid path. For our STF and Phoenix style pumps, a basic priming method is to start by running at a faster speed to fill your lines, then reduce the speed to push out any remaining air. Repeating this process can help achieve a stronger prime, though it's not always necessary. A well-primed system will deliver smoother operation, more repeatable performance, and far more reliable accuracy overall. By following these best practices, you'll help extend the lifespan of your fluid metering pump and maintain consistent performance across a wide range of applications. Keep in mind that every system is a little different, and the recommendations in this video are meant to serve as a general guideline. If you ever need support with a specific application, our technical team is always here to help. For additional documentation, specifications, and application guides, be sure to visit the Fluid Metering website. Thank you for watching.